This is problem 640 from your textbook. For this problem, we need to find CD, CF, and CG. So to do this, we could either just do the method of joints, um, or we could do method of sections and method of joints. We're going to do method of sections and then method of joints just because that's the section that we're on in the textbook. So the section that we'll draw, we'll go through, we can't go through all three unknowns because then we'll have to pick up a fourth member. So we'll just go straight through here and pick up CD and CF. And then we'll need to do method of joints to find that CG force. And so since we're doing the method of sections, we are going to, and we can do I guess we'll just do the right-hand side. It's a little simpler. With that, we do need to know that roller force there. So we'll need to do a free body diagram of the whole system. So I'm just copying and pasting this, and then we'll find that normal force at E. So I'm just going to replace those reactions with forces. So at A, we're going to have AY and AX. And then at E, we're going to have that normal force at E due to that roller. We just need to find that normal force at E so we can sum the moments. Actually, we can sum the moments about A to find that. And I'm going to make coming out of the board as being positive. So we get that 4 kilonewton force at B is going to create a negative moment, so minus 4 times 5 meters. And then I'm going over to C, so minus 4 times 10 meters. And then over here, minus 5 times 15 meters. And then minus 3 times 5, 10, 15 times 20 meters. And then plus NE times that 20 meters. That equals 0. And so then we get an NE equal to, let's see, at 9.75 kilonewtons. And that would be pointed up to get a positive. So now we can take that right-hand side section to solve for CD and CF. And so to do this, let's see, I'm just gonna so we're gonna have this one up here is CD, or yeah, CD. CD. We have this force here, which is that CF, and then this force here, which is FG. I'm actually I might make this a little bit bigger so we can see a little bit better. So then we have our angles here. So for FG, it's going down 2 and over 5 meters. So I'm just going to make a common triangle here. So down 2 over 5 meters, and then this will just be the square root of 5 squared plus 2 squared. So that'd be 25 plus 4, so that'd be square root of 29. And then for CF, it goes down 3 and over 5. So down 3 and over 5, so 3 and 5. And so that one would be the square root of 5 squared plus 3 squared. So that's 25 plus 9, which would be square root of 34. And then we have the other dimensions written on here. So I think we're ready to start solving. So we can solve for CD and CF. So if we sum the moments about point F equal to 0, oh, we need to change that roller force that we'd found. So that was 9.75 kilonewtons, which is NF, or NE, sorry. So we can sum the moments about F, and we get that CD times its moment arm, which will be 3 meters. That 5 kilonewton force is in the same line as point F, so it doesn't create a moment. The same for CF and FG. And then over here we have 3 kilonewton force, which would be in the negative direction, so 3 times 5 meters. And then the 9.75 will create a positive moment, so 9.75, and then that's also times 5 meters is that moment arm. That equals 0. So we get CD equal, do the calculations. Get a negative 11.25 kilonewtons. So CD equals 11.2 kilonewtons in compression. So I just picked the direction wrong. And that's what you get when you do that negative sign. And then we have, now we can sum the, sum the forces in the X direction or the Y direction. Since both CF and FG, both of our unknowns, have X and Y components, it's not going to really matter which. We're going to have to do both to get to that CF that we're looking for. So we'll start by summing the forces in the Y direction equals 0. So with that, the 5 kilonewton force is pointing down, so minus 5, minus 3, that's at E, plus 9.75. Then plus that y component of CF, so 3 over the square root of 34 CF, and then minus that y component of FG, so 2 over the square root of 29 FG. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Maybe just making sure I got all the y components I needed. That equals 0. So we get it doesn't really matter. FG equals 1.75 plus 3 over the square root of 34 CF, all that times the square root of 29 over 2. And then we can sum the forces in the X direction. And for that, we get CD, which is it's in compression, so it's actually to the right. So that's 11.2. And then 5 kilonewton forces in the Y direction, the 3 and the 9.75 are in the Y direction. And then we get minus that X component of CF, so 5 over the square root of 34 CF, minus, and that X component of FG, which would be 5 over the square root of 29 times FG equals 0. I can plug that into here. So we get 11.2 minus 5 over the square root of 34 CF minus 5 over the square root of 29 of FG, and I'm just replacing that 1.75 plus 3 over square root of 34 CF times the square root of 29 over 2. The square roots of 29 cancel out. That equals 0. So now I just need to do some calculations. So 5 over 2. Two, 8, 6 CF equals 0. So now I can just move the CFs over to the right side. So we get 2.14 CF equals CF equals 3.18 kilonewtons. And because we got a positive number, that means it is in tension. So we have CF. What were the ones? Yeah, we wanted to find CF, CD, and then CG. So we found CF, so we actually don't even need to find FG. Or maybe we do. Yeah, I guess we do. Because then we have to go to joint next. So if we do joint G, let's see, if we do joint G here, or if we did joint C, oh yeah, we could do, oh no. Let's see, it's GH that we want. Yeah, so, or it's CG that we need. So if we did joint C, we would have too many unknowns, but we can do this joint G. And so for joint G, we actually do need to have FG. So I'm going to solve for FG also. So FG equals, I'm just going back up to that original equation, that 1.75 plus 3 over square root of 34 times CF, which is at 3.18. Of that times the square root of 29 over 2. So FG So we get 9.12 kilonewtons. And it's in tension because I got a positive number. Okay, so now I can go to that joint G. So I'm going to draw that free body diagram for joint G. So joint G. So for G, we have GH, we have CG, We have FG, which equals that 9.12 kilonewtons. CG is what we want to find. We know some stuff about the dimensions. So FG is going to go over 5 and up 2. That's the square root of 29. And then it's the same over here, where it's over 5 and up 2. Square root of 29. And we're interested in the CG, but we need to find GH also just to get to that. So if we sum the forces in the y direction, we'd have 2 unknowns. So I'm going to sum the forces in the x direction equals 0. So we get that x component of FG, which would be 5 over the square root of 29 times that 9.12 kilonewtons, minus that x component of GH, 5 over the square root of 29 times GH equals 0. So GH is going to equal 9.12 kilonewtons also. And so now we can sum the forces in the y direction equals 0. And with that, we'll get the y component of GH, which would be 2 over the square root of 29 times that 9.12 kilonewtons, plus CG, and then plus that y component of FG, which would be 2 over square root of 29 times that 9.12 kilonewtons. That equal, or we already said that equals 0. And so that gives us CG equals, and it's going to be a negative number, so we guessed wrong. It'll actually be in compression. And so we get 6.78 kilonewtons, or negative 6.78 kilonewtons. So that means it's 6.78 kilonewtons in compression is your CG. And so then we have everything that we need. So we have CG, CG, CF, and CD. CG, CF, and then CD that we found up there. So that's it.